So I'm going to sketch A first of all. Can anybody tell me what the asymptote of the first function is? It's got one translation and it's a horizontal translation. Chris? 3 is indeed the asymptote. So the asymptote, instead of being x equals 0, the asymptote for the first one, which I do in orange, is x equals 3. And so I know that it doesn't quite touch 3. It might still be reflected, so I'm not going to do anything yet, but I suspect it comes up along 3 and over to here. What would be really nice is to know the X intercept. How do I find the X intercept? Let y equal 0. So A, let y equal 0. That gives my X intercept. If you know a bit about transformations, you might be able to work it out without letting y equal 0 and solving, but this is a foolproof method that will definitely work. I get 0 equals log base 2 of x minus 3. Here we go, it's going to be fiddly again. And 2 to the power of 0 equals x minus 3 tells me that x minus 3 equals what? What's 2 to the power of 0?
1.
So I get 2 to the power of 0, which is 1. And if x minus 3 equals 1, x equals 4. And so I've got an x-intercept at 4 and an asymptote at 3. And my function looks like this. I might look for another key point. Like, for example, 2 to the power of what equals 8 is nice. So when x minus 3 equals 8, I get a y value of 3. I could do something like that. And my y value is 3 when x equals 5, for example. Does that look about right? I don't know. Is that too steep? My x value is 3, my y value is 3, 2 to the power of... Oh no, sorry, not when x equals 5. It's not x plus 3, it's x minus 3. So when x equals 11, so it's over here. So I know it looks something like this. I could find another point, but that's basically my asymptote. Realistically, the main thing you need are the x and y intercepts and the asymptote of the function. Next one, B, 4 log base 2 of x. So log base 2 of x just goes through this point 1 and has an asymptote at 0. What do you think 4 log base 2 of x looks like? So it's got a vertical dilation that's been multiplied by 4. So it still goes, nothing else has changed. So it still goes through 1, 0, but it's a lot steeper now. So again, I might just put in x equals 2 and determine another higher point. So x equals 2 into there. 2 to the power of what equals 2 is 1. 4 times 1 is 4, so it's now this steep. And it will look like this. Be much steeper than the orange one, which doesn't have that vertical dilation. But it's still got that log shape. The third one, C, y equals log base 2 of 2x. So what does that 2 on the inside do? So you've got A, B, C and D. I'll help you out. A is the vertical dilation. You pointed that out. Thanks, Eddie. C, we've just done, is the horizontal translation. D is the vertical translation. B is a horizontal dilation. By a factor of 2. So we get the function and stretch it out by a factor of 2. Works opposite to what we expect on the inside, so we get a compression factor of 2 or a stretch of a half. Okay? But again, if you're unsure, you can still just work on some known points. So I would go there and go, well, it's if y equals 0, 2 to the power of what equals 2x, and I'll come out with a half. 2 to the power of 0 equals 2x, I'll get x equals a half. So it's now compressed into a half. I can get the x-intercept by substitution quite quickly. I should rub that off and put that here. And I'll do this one in pink there. So substitution tells me it's here. And if I put in, say, x equals 2, log base 2 of 2x is log base 2 of 4. And so therefore at x equals 2, I get 2, which is here. So it's reasonably flat comparatively, but I haven't really got that curve right, but you get the point. Looks like that. And I've just got those main points. And if I find any extra points, I'm going to mark them on there, and I'm going to note what they are. 2, 2 works. And a half, 0 works. So I've got those points on there. So get the x-intercepts, get your asymptote right, get your y-intercept if it exists, and then if you need some other points, get those other points. Be clever about it. This is what, and it's in the criteria sheet at the PSMT we're marking now, and it exists in the exams to an extent as well. Be discerning, make clever choices. Here, clever choices are things that simplify the log base 2 easily. So if you've got an 8 inside, log base 2 of 8 is 3. But if you've got a 7, it's not a nice number. So be discerning in what you're doing. And hence, can you sketch the graph y equals 4 log base 2 of 2x minus 3? So this graph has a horizontal translation of 3, and that's now where the asymptote is. It has a vertical stretch of a factor 4, so it's quite steep. It has a horizontal dilation of a factor half, so it's been pushed in, which actually makes it steeper again. So that's what the graph's going to look like. Really, really steep with a dilation, so with an asymptote at 3. So we can go through and do the same process. First of all, if I do this one in green, and sorry, my graph's going to look horrible. I'm going to rub out this thing here. If I do this one in green, 3.5 will be my x-intercept. Let y equal 0 solve, you'll get 3.5, I promise you. 3.5 is my x-intercept. My asymptote is at 3, and it's quite steep. Just to make sure I get it right, I might just find one other coordinate that works. It's going to be nice. So if I make x equal to 7, 7 minus 3 will be 4, and 2 times 4 is 8. So at x equals 7, y equals 3. And so 7 and 3 is there. So it's actually quite flat. Is that what I was expecting? Oh, because of the 4, sorry. 4 times 3, so it'll be 12 up here. That makes it better. So that's quite steep, and it looks like that. So I've just bitten a bullet and got another coordinate, and then I can connect it easy as. But see how that's a mixture of just finding coordinates, but also having an understanding of the shape and an understanding of transformations. That's going to be really important. Does anybody have any questions on that?